Okay, I wanted to talk about a few different combinatorics techniques, distinguishable permutations, ordered permutations, and unordered permutations. But first, I want to start off with an example. The example I want to start off with is simply just A, B, B. And a question might be, how many ways can we arrange these two A's and these two B's so that they look different? So I'm going to go ahead and list them all out here. So we already have A, B, B. We could also have A, B, and then next we could have A, B, A. Okay? A few more. We could also have B, A, B. We could do B, A, and then the last remaining is B, A. Okay? So I want to look more specifically at the first one, just A, B. And I want to point something out. In that A, I can't tell the difference whether I did AA or B or BB. In other words, I didn't necessarily make this distinction. So I could have said maybe A1, A2, B1, B2. This way I can distinguish between the two A's, I can distinguish between the two B's, and we have a few other arrangements. So I could do A1, A2, but then I could switch the B's, B2, B1, or I could switch the A's. A2, A1 first, then we can have B1, B2, A2, A1, B2, B1. Now, when I'm distinguishing between the two A's and the two B's, that gives me 4 ways. Okay? That means for each one of the 6, that we have up here, where we couldn't distinguish between the two A's and the two B's, each one of those has 4 additional arrangements that we could think about. Okay, so let's break this down. So the number of ways to order 4 things, that would be 4 factorial or 24. Okay, and then note there that 6 times 4, that would get us to 24. Okay, but for each one of our 6 arrangements, I can't tell the difference between the two A's or the two B's. So one way of thinking about this would be taking the total number of ways arranging our 4 objects and then dividing it by, I can't tell the difference between the two A's, and I can't tell the difference between the two B's. And if I did that, 4 factorial would give us 24, 2 factorial is 2, 2 factorial is 2, and that would give us a total of 6 ways, so that matches. And to do any sort of distinguishable permutation, distinguishable arrangements, it simply is n factorial all over, say, k1 factorial, k2 factorial, so on and so forth, until we would get to km factorial, where each of the k's would be the number of that particular distinguishable, rather indistinguishable object. And then one thing to note here is that if you'd add up all of the k's, they need to add up to the total number of objects. Okay? So let's look at a very classic example. Classic example would be how many distinguishable arrangements are there of the word, and I chose the word abracadabra. So very simply, what we could do is first total up the total number of objects that we're dealing with, and there are 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then I could total up each one of my indistinguishable objects. So first I might total up the number of A's. I have 1, 2, 3, 4, 5. Next would be the B's, and there are 2. Next we could have R's, 2 again. And then we have the C next, just 1. And then lastly, we would have the D. Not a B, a D. And then obviously it would be good anytime that you're doing this to make sure that you counted everything. 5 plus 2 is 7, plus 2 is 9. 2 more brings us to 11. Chucking this into our formula, that would be 11 factorial all over the total factorials of the objects that were indistinguishable. So that would be 5 factorial, 2 factorial, 2 factorial. I'm not going to write the two 1 factorials. Each one of those would just give me 1. Chucking this into a calculator would give me 83,160. Okay, of course, there's other problems that are similar to this, but aren't necessarily phrased in the term of distinguishable arrangements of words. So I'm going to do very similar question, how we work it, but the wording is different, and I'll kind of explain how it ends up boiling down to a distinguishable permutation. So the next question, you have 10 different contracts that you want to distribute between a big, medium, and small firm as follows. 5 to the big firm, 3 to the medium firm, and 2 to the small firm. How many ways can you distribute the contracts? And so when I think about this problem first, I want to note that all of these 10 contracts, they're different. So I want to think, so I could have contract 1, contract 2, 3, 4, 5, 6, 7, 8, 9, 10. And one way that I could distribute these contracts among my big, medium, and small firm would be to say, send the first 5 to the big one, the next 3 to the medium, and the last 2 to my small firm. Okay? When I view it this way, this is just a distinguishable, word, and then every sort of, and if I'm looking at a particular distinguishable word, it tells me where to send, the first contract, where to send the fourth, so on and so forth, based off of the arrangements of the letters in our word. So here we had 10 distinguishable contracts. I wanted to send 5 to my big firm, 3 to my medium firm, and then 2 to my small firm. I would just put this into my formula. So we had 10 total objects that we were wanting to order, but I couldn't distinguish between 5 of them for the big, 3 of them for the medium, and 2 for the small. Working that out, that would give me 2,520. Okay, the next question, again, it's going to be very similar, just a little different flavor. You work at an advertisement firm and have 15 volunteers for 3 different focus groups. How many ways can you evenly distribute the 15 volunteers? So here we have the 15 volunteers. We have 3 different groups. And that would mean that we would need to put 5 people in each of our groups. And here I just want to kind of jump straight to the formula that I would use. So one I could do, I have a total of 15 people. But then for each of my 3 groups, there are 5 factorial ways to arrange those people. I don't care about how I can arrange those people. They're going to one of my 3 groups. Since I'm doing 3 of them, I could just cube that. Okay? And then working that out, that would give me 756,756. And then for the last question, I want to hit on one that would be an unordered partition. So you are a teacher with 20 students in your class. You need to split them up into pairs, each treated the same. How many ways can you do this? And this is going to be very similar to the previous problem with just one change. And that change is that I'm treating each one of my groups the same. If you remember in the previous problem, we're wanting to split the people into 3 different focus groups. Here, if I'm just splitting people off into pairs and I'm not treating any of the pairs differently, then they're indistinguishable between the pairs. So here it would just be the 20 factorial. That's a total number of ways of arranging our 20 students. In each group, there's going to be 2 people, and I don't care about how those 2 people are ordered, so I'm dividing out 2 factorial. We'll have 10 groups, and then finally the last thing, I have 10 groups that I'm not treating any of them differently. I'm not saying, this is the group that's going to be in charge of, say, holding a flashlight. This one's not going to be in charge of snacks. I'm treating every single group the same, and the way of ordering 10 things would be 10 factorial. Then working that out, that would be 6,054,700,029.75 ways. Okay? Thanks for joining my video. Have a good one.